The top view of a line capital PQ, 75 mm long, measures 50 mm, and the front view measures 60 mm. The NP is 30 mm above HP and 15 mm in front of VP. Draw the projections of the line and find the true inclination with HP and VP, and find the distance between the end projectors. So the NP is 30 mm above HP and 15 mm in front of VP. So when you look from the front view, we can see the distance NP, capital P, above HP by 30 mm. So when it is projected onto the vertical plane, we can see the distance of NP above XY line by 30 mm, and mark that point as P dash, small p dash. Then when you look from the top view, we can see the distance in front of VP, that is this distance, which will be 15 mm. And when it is projected onto the top view, that is on horizontal plane, you will going to get this point, which will be 15 mm in front of VP, which will be small p. Then here he has given only the front view and the top view, but the true length, but he has not given any inclination. So we need to find out that. So we know that when the front view line is parallel, is correspondingly the top view line will be true length, and when the top view line is parallel, its corresponding front view will going to be in true length. Now we will going to find out the true length in VP. So that means the line has to be parallel to VP. So you make the line parallel to VP. Which is the line which I have to make the line parallel to VP? The top view line. So which is the top view line? The top view line is 50 mm. So from P, you take the distance of 50 mm parallel to VP. That means P is in front of VP by 15 mm, and the Q1 is also in front of VP by 15 mm. So when you make this line top view, which is parallel to VP, and when it is projected here, you will go to get this point here, P dash, that is capital P in space, and you project this Q1 also in space, vertically up, it is in space. Then with P as center, take the radius of 75 and cut an arc on this, so that you will going to get this capital Q1, which is PQ1. This is the line which is in space. Line is parallel to VP because NP is 15 mm in front of VP and capital Q1 is also 15 mm in front of VP. So you are going to get this line parallel to VP. But when you project this line in the front view, when you look from the front view, P will be here. So P dash, we got this point, and Q1 is here. When it is projected, you will going to get this point here. So then we will going to get the line. You will going to get this P dash Q1 dash is the line which will going to be the true length in the vertical plane. The length of this will going to be 75 because this line is also 75. Naturally, when it is projected, you will going to get this line also. It's by 75 mm. So you will going to get the locus of Q in the front view. So you are going to get the locus of Q here. Now, so we got the Q1 here, which is the true length. Now we will going to take the front view now. When you want to take the front view, so what is the the front view line is made parallel, its corresponding top view will going to be in the true length. So that means here end P is above HP by 30 mm, and also this Q2 also should be above HP by 30 mm. So from here you draw a horizontal line which will be, so that from here you measure PQ1, which will be, so here, so PQ1 which will be parallel to HP. When it is made to parallel to HP, so from P you measure the distance which is equal to, measure 60 mm. So from here you draw a horizontal line, you will going to get the distance which will going to be 60 mm. You measure this distance 60 and draw a vertical projector here, and then with P as center, cut an arc on this, so that you will going to get this point which will be Q2, which is length of this line will be equal to 75 mm. So this is the front view line. When it is made parallel, you will going to get the true length in HP. So P is above HP by 30 mm and Q2 is also above HP by 30 mm. So when this is being projected to the top view, which will be on horizontal plane, so you are going to get this line which will be PQ2, which will be true length in HP, joined with a little bit darker than the projector line. So we are going to get PQ2. So then draw a horizontal dash dot line which will going to be the locus of Q in the top view. So this will be capital Q2 and this will be capital P. Now how do you are getting this point? So because when this projected, so the front view line is made parallel. This parallel to HP can be seen in VP. So from P dash, so you draw a horizontal line which will be equal to P dash Q2 dash, which will be 60 mm. So you measure 60 mm here and draw a vertical projector here, and then draw the vertical projector here, and then you take from P, which will be point, from this point you take the radius of 75 and cut an arc on this vertical projector. You will going to get this point which is Q2. So this is in space. This is how we got it in when you are doing it by construction. So you will going to get this dash dot line. This will going to be the locus of Q in the top view. Then join P and Q2 with a little bit darker than the projector line. So you are going to get this point. Now we need to find out the front view and the top view. So because now in the front view Q2 dash is here, that is Q2 dash is above HP by 30 mm. But actually because due to the presence of the true length in HP, so the locus of Q is here, that is above HP by some distance. With P dash as center, take the radius of P dash Q2 dash, draw an arc such that it will going to cut the locus of Q in the front view here. Then mark this point as Q dash, and then join these two with a dark line, that is P dash Q dash with a dark line. So this will going to be the apparent inclination with respect to HP, which is alpha, and this will going to be the true inclination with respect to HP, which is going to be theta. Now similarly, now because due to the presence of this true length in HP, so the line is parallel to HP, and this is the locus of Q in the top view. So now in the top view, the Q is in front of VP by 15 mm, but because due to the presence of this locus of Q, the Q will going to be in front of VP by this distance, such that without altering the length of the line. So with P as center, take the radius of PQ1, draw an arc such that it will go and draw an arc which will going to cut the locus of Q here. So you are going to mark that point as Q. Then join P to Q with a dark line which will going to be of 60 mm length. Sorry, 50 mm length. So this will going to be the apparent inclination with respect to VP, which is beta, and this will be true inclination with respect to VP, which will be phi. Now actually when this point from Q, if you draw a vertical projector, and from Q dash you draw a horizontal projector, both will going to meet at this point. Then this will going to be the PQ. This will going to be the actual length of the line in space. So this will going to be Q. So when you are rotating like this, when you made it parallel to HP, so this is how it will going to take the rotation here in the front view. Similarly, when you rotate with respect to P and Q here, with P as center, when you rotate it and made it parallel to VP, that is Q1 in front of VP by 15, and PQ, P is also in front of VP by 15, that is PQ1 is parallel to VP now. So when you are rotating like this, what will going to be the image? The image will going to be is rotated from here to here. So this is the actual path which has been traced by this. But since you are given the front view, so when it is in the front view and when the top view is made parallel, so corresponding true length is in this, true length is in VP. When you make the front view make parallel, then the true length will going to be in HP. So that is in the top view. So this is how we can analyze it in the 3 dimension. Now we will going to solve the problem in 2 dimension. So that is in the sketchbook. First we will going to draw the XY line and mark VP and HP. Then the NP is 30 mm above HP. From XY line you measure 30 mm above the XY line and draw a horizontal line. And similarly 15 mm in front of VP, from XY line you measure 15 mm and draw a horizontal line. And consider any point and draw a vertical line here and mark this point which as P dash and mark this point as P. Then when the front view line is made parallel, then its correspondingly the top view will be in true length. When the top view line is made parallel, its corresponding front view will going to be in true length. So first we have only this line and this vertical line. We don't have any other line, and we don't have even locus also. So first we are going to make the top view line parallel. The top view line is 50 mm. So from P you measure the 50 mm and draw a horizontal line and mark this point as Q1. The length of the PQ1 will be 50 mm and draw a vertical projector to the front view. Then with P dash as center, take the radius of 75 and cut an arc on that vertical projector. You are going to get this point as Q1 dash. Since this line is parallel to VP, so you are getting the true length here, and you mark this point as capital P and capital Q. Then join P dash to Q1 dash with a and P dash to Q1 dash with a little bit thicker than the true length line, thicker than the projector line, and then draw a horizontal dash dot line which is going to be the locus of Q in the front view. Similarly, now if you want to find out the true length in HP, you make the line parallel to HP. That is, P dash is above HP by 30 mm and Q2 dash is also above HP by 30 mm. That is, when the front view line is made parallel, what is the length of the front view? The length of the front view is 60 mm. The length of the front view is 60 mm. So here, from here you measure the distance of 60 and you mark this point which is going to be the 60 mm and make it parallel, and then draw a vertical projector to the front view, top view. Then with P as center, take the true length of the line which is equal to 75 mm and cut an arc on this vertical projector, so that you are going to get this point top view which is Q2. Since the line is parallel to HP, so you are getting capital P and capital Q, and write capital P and capital Q, and draw a join between P and Q2 with a little bit thicker than the true length projector line. So here draw a horizontal dash dot line which is going to be the locus of Q, and mark this as the locus of Q. So now we got the true length. Now we got the locus of Q in the top view and also locus of Q in the front view. So next is, since we have the point Q2 dash which is above HP by 30 mm, but due to the presence of this true length in the front view, we have the locus of Q here. So with P dash as center, P dash Q2 dash as the radius, you draw an arc such that it will go to cut the locus of Q at this point. You mark this point as Q dash and join P dash Q dash with a dark line which will going to be the front view. Similarly with P as center, because due to the presence of the locus of Q here in the top view, because we have the true length in VP which is at this point, and this is the locus of Q. With P as center, you take the radius of PQ1 which is 15 mm in front of VP. Then draw an arc such that it will going to cut the locus of Q here. So this point will going to become small PQ, and join small PQ with a dark line. And then by using the scale, when you join between Q and Q dash, both will going to lie on the same line. So the distance between the end projectors between P and Q will be D is equal to question mark. You measure the distance from here to here, which will be 21.79 when you are doing it in computer. When you are doing it in manual, it will be 22. Similarly, by using the protractor, you measure the true inclination with respect to HP, which is theta. In CAD, you will going to get 48.19, but in computer, when you are doing it in manual, it will be 48 degrees. Similarly, when you are measuring the true inclination with respect to VP by using the protractor, phi is the angle which will be equal to 36.87 when you are doing it in computer. When you are doing it in manual, it will be 37 degrees. So this is how we will be able to solve this problem in sketchbook. Now we will going to analyze the same thing by considering this step by step. In the first step is, first we locate the P dash and P by 30 mm above HP and in front of VP. Then you make the top view line parallel, so which is 50 mm, and then draw a vertical projector to the front view and measure 75 mm and cut an arc on this. You are going to get this Q1 dash, you are going to get this Q1. So you will get this P dash, and this will going to be the inclination which you measure, which will be 48.19. So now we don't have this locus again, but here which is considered only because we have taken this as the locus which has been there, we have copied from here. So we will not have this, but we can get this point directly. Then we need to rotate this only when you get the locus. So that we are going to show in the next step. slide. We can see here, when the front view line is made parallel, you will going to get the true length in HP. So this is the true length in, this is the parallel to HP. So we are getting the true length here. So we made the front view line parallel, that is 50 mm here, that is 65, that is 60 mm here. You make that line parallel and then project this line into the top view. So then you take 15 mm, 75 mm with P as center, cut an arc on this vertical projector, so that you will going to get this locus. You got the locus of Q. So in the top view, we had made this line parallel, which is 50 mm, and now you rotate that, you will going to get this PQ here. In the front view, you made this line parallel, which is 65 mm. Then you rotate it back so that you will going to get the locus here. Because we are already having the locus, it will going to cut the locus here. You will going to get this 2 dash and join these two. So this will going to be the length of the line, which is going to be 60 mm. By mistake we have typed 50, but it should be 60. So here, when you join between these two, you will going to get, this is the distance between the end projectors. You measure the distance between the end projectors and also true inclination with respect to VP, which will be 37 degrees. So this is how we can solve the problem in stepwise, and the final answer what we expect is only this one. These are all just for the analysis purpose.